So our next type of equation to solve in 1D is solving radical equations. So a radical equation will have some type of radical like a square root or a cube root are the most common ones. So here's the steps up at the top to solve. So to solve a radical equation, first, step 1, we have to isolate the radical. Then step 2, we need to eliminate the radical. So that means we have to get rid of that radical. And the third thing we do have to remember is to check our solutions because like rational equations, we can have extraneous solutions. So we do want to make sure we check our solutions when we're solving radical equations. Okay, so when we say eliminate the radical, let's refresh our memories on how we do that. So say we have a square root, like say we have square root of x. Hopefully we remember to get rid of a square root, the opposite or inverse operation of a square root is to square it. So a square root and squared get rid of each other. And so the square root of x squared would just leave us with x. So that's how we eliminate, is we do whatever power we need to do to get rid of the radical. Or we know if it's a cube root of x, the way we get rid of a cube root is I have to put it to the third power, or I cube it. So the cube root of x cubed, the cube root and the cube would get rid of each other and we'd just be left with x. Those are the most common ones we see. Although we could see fourth root, if we have a fourth root, we'd have to put it to the fourth power. Or if we had a fifth root, we'd have to do the fifth power, etc. Okay, so let's solve these equations here. So let's do these examples together. So number 6, here's the equation we have, 9 minus square root of t plus 2 equals 5. We're trying to solve for t. So I see that this is a radical equation. It has a radical. So step 1 is to isolate the radical. I got to get the radical part by itself. So to do that, I need to get rid of this 9 and also this minus sign in front. Okay, so step 1, I'm trying to isolate radical. To do that, first get rid of the 9. Notice this is not 9 multiplied by this, it's 9 minus this. So I got to get rid of the 9 first. So to get rid of the 9, I subtract 9. And whatever I do to one side, I do to the other. That will get rid of that 9 that's in front. But keep in mind, we still have that negative in front. So I have negative square root of t plus 2 equals, on this side now I would have negative 4 because I subtracted 9. Now I still have to get rid of this negative in front of the radical before it's by itself. Remember, that's just like a negative 1. So to get rid of that negative that's multiplied by the radical, I could divide both sides by negative 1. That's the negative 1 divided by negative 1 will divide out to give us a positive 1. So now I just have t plus 2, square root of t plus 2 equals positive 4. Okay, so that's all part of step 1. I had to isolate the radical. Okay, so now the radical's by itself. So now step 2, I could get rid of the radical. The way we get rid of a square root, so this is a square root. To get rid of a square root, I'm going to square both sides. So to get rid of the square root, I square this side, but it's an equation, so whatever we do to one side, we do to the other. So we square both sides. So on the left side, the square root and square get rid of each other, and we're just left with t plus 2. On the right side, 4 squared, I actually need to evaluate that. 4 squared is 16. Okay, so I have t plus 2 equals 16. Now that I got rid of the squared part, I just have to solve for t. This just happens to be a linear equation. after I got rid of the radical. So I'm just trying to get the t by itself. So subtract 2 to get the t by itself, and we get t equals 14. Okay, so there is our solution. I am not quite done yet because we do always want to remember to do step 3, which is to check. We want to check for extraneous solutions. So when we're checking, we always are plugging our equation into the original equation. So we're using the original equation, and I'm plugging in the 14 for the t. Okay, so it looks like this: 9 minus square root of 14 plus 2 equals 5. Okay, so I plug the 14 into the t in the original equation. And then I'm simplifying both sides of the equal sign to make sure that they're actually equal. So on the left side here, I want to simplify. So square root of 14 plus 2 is 16. Square root of 16 is 4. So on this side, we have 9 minus 4. So on the left side, we have, after we simplify, we get a 5. On the right side, we have a 5. So we get 5 equals 5. That is true. That means that this is a valid solution. So again, we always want to check our work because we could have a case where we have an extraneous solution. If you don't feel like doing the arithmetic, you could always use a calculator to help you check. I can just type this left side into the calculator and make sure it's equal to what I have on the right side. So feel free to do that. If you don't want to check by hand, feel free to use calculator to help you check. An easy one to use is Desmos. So you go to desmos.com. I am sure you have seen Desmos before from Algebra 2. Go to graphing calculator. And I'm just going to type in that left side of my equal sign. It was 9 minus square root, here's the square root, of 14 plus 2. And then that gives us a 5. So notice we get a 5. So rather than doing this arithmetic, I would just know that I have 5 equals 5, and it would work. So feel free to check your work or check your solution on a calculator, but don't forget to check our work. Okay, so that was number 6. We had a square root. So to get rid of the square root, I had to square both sides. If we look at number 7, notice it is a cube root. We have 2 cube root of 5x plus 1 minus 2 equals 10. Okay, so let's solve. I see that it's a radical equation. So step 1, isolate the radical. I got to get the radical part by itself. It has this 2 in front, and it also has this minus 2. I have to get rid of them both. I want to get rid of the minus 2 first. Okay. So to get rid of the minus 2 right here, I'm going to add 2 to both sides. So I got rid of that. So I have 2 cube root of 5x plus 1 equals 12. Okay. Then I still have to get rid of the 2 in front. So this is multiplied. So to get rid of the 2 that's multiplied by this radical, I have to divide by 2. Of course, whatever I do to one side, I do to the other. So those divide out. Now I have cube root of 5x plus 1 equals 6. Okay, so that was all part of step 1. Isolate the radical. But then step 2, we want to get rid of the radical. This time it is a cube root. So to get rid of a cube root, we're going to cube both sides. Okay, so here on this side, to get rid of the cube root, I cube it, or that means to the 3rd power. So I have to do the same thing on the other side. So on the left side, the cube root and cube will get rid of each other, and we're just left with 5x plus 1. On the right side, I have 6 cubed, so I actually need to evaluate that. That means 6 times 6 times 6. If you're not sure, feel free to use a calculator. 6 to the third power is 216. Okay, so we have 5x plus 1 equals 216. Then I solve for x like we normally would. Okay. Once again, this is a linear equation. So I'm just trying to isolate the x. So to get the x by itself, I subtract 1. So I have 5x equals 215. And then divide by 5. And we get x equals 215 divided by 5. Again, if I don't know that in my head right away, I'm just going to use a calculator. So 215 divided by 5 equals, whoops, is 43. Okay, so x equals 43 is our solution. Okay, so we have our solution, but I am not done until I check. We always want to check for extraneous. So when we're checking, we're plugging it into the original equation, and anywhere there's an x, I'm plugging in 43. Okay, so here's what it looks like when I plug in 43. 2 cube root of 5 times 43 plus 1 minus 2 equals 10. Okay, now, personally, I don't want to do all this arithmetic, but I do want to check. So I'm going to just plug this entire left side into my calculator and see what I get. So I'm going to plug that in. All right, so we have 2 cube root. So to find the cube root, it's not on my in my menu right here, but if I go to functions, it's over here under miscellaneous. This allows me to put in any type of root right here. So this one, cube root, and then inside the cube root, we have 5 times 43, whoops. 5 times 43 plus 1. Then outside of the radical, so using the side arrow, I have a minus 2. Okay, so plugging that all in, notice we get a 10. That means the left side of my equal sign is 10. That's what we got on our calculator. And then equals 10. The right side of our equal sign was also 10. So this is a true equation. It makes the equation true. So that means x equals 43 is a valid solution. Okay, keep going. We've got a couple more. We got 2 more examples, and then we'll do some practice. Okay, so number 8 looks a little bit different because there's actually 2 radicals. So when we have 2 radicals, we're still going to do the same thing. Step 1 is to isolate the radical. If there's 2 radicals, just pick which one you want to isolate first. I'm going to go ahead and get this one by itself, the square root of 2x minus 15. So I need to isolate the radical. But if we look at that, it's already done. That radical is already by itself. So step 1 is already done. So then step 2, we want to get rid of the radical. Again, I'm focusing on this radical. It's a square root. So to get rid of a square root, I have to square both sides. So I'm going to square the left side to get rid of this radical, but it's an equation. So whatever I do to one side, I do to the other. Okay, so I'm squaring both sides. On the left side, the square root and the squared get rid of each other, and we're just left with 2x minus 15. So we got rid of that radical. Notice what also happens on the right side. It actually makes this pretty easy because on the right side, I have square root of x plus 5 squared. So again, the square root and squared are going to get rid of each other, and we're just left with x plus 5. So in this case, after I squared both sides, I actually got rid of both radicals. So now I have, again, just a linear equation. 2x minus 15 equals x plus 5. And I'm just going to solve for x. So I want to get the x's on one side and the numbers on the other. So on the left side, I want to get rid of the minus 15. So I'm going to add 15. Okay, I'll get rid of that. On the right side, I want to get rid of the x. So I'm going to subtract x to get rid of that. So then on the left, I have 2x minus x. That's like a 1x. So that just leaves me with a 1x. And then on the right, 5 plus 15 is 20. Since we just have 1x equals 20, we don't really have to write the 1. That gives us our solution, x equals 20. Okay, so we've got our solution. But we are not done until we check. So we get x equals 20, but we want to check to make sure it works. We always are going to plug in our equation into the original equation. And in this case, there's x's on both sides of the equal sign. So make sure you plug in the 20 for both places there's an x. So when I do that, I would have on the left side, 2 times 20 minus 15 under the square root equals square root of 20 plus 5. And in this case, you'd have to simplify both sides of the equal sign and see if they're equal. This one would be, again, you could use a calculator, but this one's fairly easy to do without. This would be 40 minus 15 under the radical. So that would be square root of 25 equals, on this side, square root of 20 plus 5 would also be square root of 25. Okay, so the two sides are equal. So x equals 20 is a valid solution. Okay, those 3 examples we did, all 3 of them ended up with a linear equation after we got rid of the radical. So our last example, number 9, this is not going to be quite as simple. This is going to be a little bit more involved. It's going to involve more algebra. So this is definitely more of an algebra 3 type of problem. So here's our equation. 4 plus square root of negative 3m plus 10 equals m. The thing that makes this a little different is there's an m, so we're trying to solve for m, but there's an m under the radical here, and there's an m outside the radical here. But we follow the same steps. All right, so step 1 is to isolate the radical. So here's the radical part here. So to isolate the radical, I got to get rid of this 4. So to get rid of the 4, I'm going to subtract 4. And it's an equation, so whatever I do to one side, I do to the other. So on the left side, if I subtract 4, get rid of that 4, and I'm left with square root of negative 3m plus 10. So on that side, now the radical's by itself. On the other side, be careful what we have here, because don't forget we had that m there already. And I can't combine those. Those are not like terms. So I would just have to write that as m minus 4. Okay, so that's step 1, isolate the radical. So we have square root of negative 3m plus 10 equals m minus 4. All right, now step 2 is to get rid of the radical. This one, a square root. So to get rid of a square root, I have to square both sides. Okay. So on this side, on the left side, I'm going to square this to get rid of the square root. Now on the right side, I have to square this whole side. So just like I do on the other side, I'm going to put this in parentheses and square it. Okay, so m minus 4 squared, or to the second power. All right, so on the left side, that's easy to simplify because the square root and squared just eliminate each other, get rid of each other, and we're left with negative 3m plus 10. Now on the right side, we have to be careful right here with what this means. Remember, when something is squared, it means we're multiplying it by itself. So I actually have to multiply. If I have m minus 4 squared, I actually have to multiply m minus 4 times m minus 4. M minus 4 times m minus 4. So I actually want to multiply that out. I'm going to either use distributive property or box method. I'm going to go ahead and use box method over here. So I'm multiplying m minus 4 times m minus 4. If I do that, I would have m squared minus 4m minus 4m, and then this box would be plus 16. Okay. So then I can combine the minus 4m and the minus 4m together. Those are like terms. So we would end up with m squared minus 8m plus 16. So that's what we have on the left side, or sorry, at the right side. M squared minus 8m plus 16. That comes from multiplying out m minus 4 squared. The right side, we still have negative 3m plus 10. Okay, so already we've done more algebra, but now I'm going to have to do even more algebra, because after I've multiplied this, after I've squared both sides, I have a quadratic equation. Okay, we have the m squared. So rather than just being a linear equation, I have to solve a quadratic equation. The method we usually try for quadratics is I'm going to try to factor, but before we factor, don't forget we have to get one side equal to 0. Okay, I'm going to go ahead and get the left side equal to 0 because I want to keep the m squared where it is. So to get the left side equal to 0, I have to get rid of the minus 3m, so I'm going to add 3m. So add 3m to both sides. That adds up to 0 there. And then I also have to get rid of the plus 10. So subtract 10, that gets rid of that 10. So now I have a 0 on the left. And on the right, I have m squared. Here I can combine the negative 8m and the plus 3m. So that gives me minus 5m. So m squared minus 5m. And then I can also combine the 16 and the minus 10. So that'd be plus 6. Okay. Then I can solve this quadratic equation by factoring. I can factor this trinomial. Since the leading coefficient is 1, I can factor this into 2 binomials. I can use the shortcut. I have m and m as my first terms. I'm looking for numbers that multiply to be positive 6 and add up to negative 5. Multiply to positive 6, add up to negative 5. So those two numbers would be 2 and 3, but they both have to be negative. So negative 2 and negative 3. So those are my factors, m minus 2, m minus 3, and it's still equal to 0. So then I have to solve. So set each factor equal to 0, m minus 2 equals 0, m minus 3 equals 0, and solve each equation. So this one I add 2. So we get m equals 2. And on this equation, I add 3 to get the m by itself, and we get m equals 3. Okay, m equals 2 and m equals 3. All right, finally, we've got our solution. So as we can see, our algebra, there was a lot more algebra here. I had to multiply these out here. I had to square that. And then I also had to solve a quadratic equation on this one. Okay, but don't forget, I'm not done yet until I check. So the last step is to check. When we check, we need to plug in the numbers into the original equation. And I actually am going to plug in the numbers separately. So I have to plug in both. Okay. So if I'm plugging in the 2 first, notice there's actually 2 places where there's an m. So I have to plug in the 2 to both places. Okay. So here's what it looks like. 4 plus square root of -3 times 2 plus 10 equals 2. Okay. So I plugged in the m for both places there's an m. Okay. Now I want to check if that one works. I can use the calculator if I want. So I'm going to plug this side into the calculator and see what I get rather than doing it by hand, although feel free to do it by hand as well. So if I plug that into the calculator, it was 4 plus square root of -3 times 2 plus 10. Okay. All right, and that gives us a 6. So the left side here, we'd end up with a 6 on the left side after we simplified all this equals 2. Is that true? Does that make the equation true? 6 equals 2? Not true. That means this solution, m equals 2, is extraneous. So that one is not a solution. So we checked that one. I still need to check the 3 though. So now let's check the 3. Again, when we're checking, we're plugging the numbers into the original equation. So plugging the numbers into the original equation looks like this. Four plus square root of -3 times 3 plus 10 equals 3. Okay, so notice I plugged in the 3 for both places. There is a 3 in the equation. So here and here. Then, like I did before, I'm just going to do this on the calculator. Especially since I already did it once, this will be really easy. On my calculator, I'm just going to go in and change this 2 to a 3. Okay. When we do that, I get a 5. So when I simplify that to check, we get a 5 on the left side. So that time we'd have 5 equals 3. Is that a true equation? 5 equals 3? That's not true. It's not equal. So this is another extraneous solution. Okay, so in this case, both solutions are extraneous or both solutions don't work. That means there is no solution. Okay. Now, sometimes there's one solution. Sometimes one of the solutions work. Sometimes both of the solutions work. And in this case, sometimes none of the solutions work. So that's why it's important to always check our work, because we could have extraneous solutions.